Hello, I'm going to walk through an example of uniform cost search or cheapest first search using the example from AI class. When I do this though, I'm going to keep track or draw explicitly the search tree that arises as you do the search because I think it's useful. So that will be one data structure that we construct. The other thing that we need to keep track of is those states that we have explored. Just a reminder on terminology, or a note on terminology first. The agent is going from city to city, so the state that the agent is in at any point in time is the city that the agent is in. So the cities are their state space, define the state space. In our search tree though, we keep track not just of individual states, but the path to get to those states. So to do that, each node in the tree has a city and its parent, and obviously that city has another parent. And also for an algorithm like cheapest first, we need to know the cost of a path. So we'll keep that information. So we will begin with the initial path is just Arad going nowhere, and the cost of that path is 0. But when we start the algorithm, we will immediately expand Arad, and it's got 3 places you can get to directly from it. I'm going to use 2-letter abbreviations. So we've got ZE, C, SI, and TI. And each of these is a cost associated with it. 75 to get to ZE, 140 to get to C, and 118 to get to TI. And that's our first node explored. That's Arad. When we have a tree like this, the frontiers of the tree are the leaves of the tree. So when we talk about our search frontier, we mean those nodes that are at the leaves of the tree. And in a cheapest first search, those nodes are treated as a priority queue. So when you decide to expand one of the nodes, you expand the lowest cost one. So obviously in this case there's 3 possible nodes, and the lowest cost is ZE with 75. So we expand that. From there, we've already dealt with Arad, and we're now going to expand ZE. And from there Arad is already explored, so there's only one possible next state, which is Oradea, OR. And the cost to get there is the cost of 75 that we took to get so far, and then another 71, which makes 146. So that's Z expanded. Now these are the leaves of our tree. The lowest cost leaf is T, so we need to expand that. That's down here. T is the third one to expand. There's only one possible next state, is Lugoj, Lu. And the cost to get to it is 118 to get this far, and then another 111, giving us 229. That's our third node. So that's that expansion finished. We now scan our queue again. The lowest cost now is C, CBU. So from CBU we're going to expand that. And it has got 3 next neighbors, Oradea, Fargaras, and RV we'll call that. So OR at some cost, FA at some cost, and RV at some cost. We'll compute the costs as 140 plus the additional distance. 140 plus 151 gives us 291. For FA it's 239, and for RV it's 220. And that's C explored. Now we will scan our frontier, the leaves of our tree, and look for the lowest cost one, because that's our priority for expansion, and here it is, OR. So that's what we expand next. When we expand it though, we see that it has no next nodes. Both ZRInd and CView are already in our explored list, so there's nowhere we can go from this. So this is, in a sense, a dead end. We will stop it there. By the way, ORADDEA also occurs here in the search tree. That's perfectly fine. This node has a different parent, therefore that it is a different node from this node, even though it's both nodes correspond to the same end state. They correspond to different roots, and therefore they have different sets of parents, therefore they're unique. So we scan our list of nodes again. The lowest I think now is ORV. So ORV has two possible children. CView is ruled out. There's CR and PI. At some cost, and PI at some cost. And again the cost is 220 plus, for CR, another 146, which gives us 366. And for PI, it's 220 plus another 97, which is 317. And that's ORV expanded. So then, we once again scan our leaves. The lowest numbered now is Lu over here, so that's the next one to be expanded. And we can see again it is only one possible next neighbor, Mehadia, or Me, M-E, and the cost for that is 229 plus another 70, making 299. Again we scan our frontier. We see the lowest now is Fa, Fagaras, and cannot, next neighbor since CView doesn't count because it's already expanded. So the only possible next neighbor is Bucharest, which happens to be our goal, but we're not done. So that's Bu. And the cost to get there is 239 that we previously cost, plus another 211, which makes 450. Now we will scan again our set of candidates, or frontier. The lowest cost candidate now is OR, but OR is already in our explored list, so that's a dead end. And we don't add it to our explored list because this is a set. Everything can only be contained in the set once. So now we have our frontier again. And the lowest cost node on that frontier is Me. So let's expand that. This is this one here. Oh, I forgot to note Fa was already expanded. So the next one to note is Me. At 299. Its only possible next node is Drobeta, Dior. And the cost to get there is 299 plus another 75, just 374. And that's Me expanded. Again we scan our frontier. The lowest cost node on the frontier now is P. And P, Putesti here has two candidates again, CR and Bucharest. Some cost, and Bucharest at some cost. The cost for CR is 317 plus another 138, which is 455. And for Bucharest, it's 317 plus another 101, which is 418. There's our frontier still. Note now again, it's no problem to have Bucharest appearing twice because these are different nodes with different costs and different parents. And the same for Craiova. So that's P expanded. Next lowest node is CR. So we expand that. Craiova. These two are already on our explored list, so the only possible next one is Drobeta, with in the distance is 366 plus another 120, that's 486. That's CR expanded. Again, we scan our priority list. There's DR. So now we're going to expand DR, but we see that its next nodes are already explored, so that's a dead end. Now here's our priority, here's our frontier, is Bucharest at 450, DR at 486, CR at 455, and Bucharest again at 418. Clearly the lowest cost node on this list is Bucharest, so we expand that. We look at it and see that it's our goal. Since it's our goal, this means this is our solution. And our solution is to get to Bucharest. You go from Arad to Sibiu to RV to Putesti to Bucharest at a total distance of 418. If we need to know how many nodes in total we expanded in order to find our solution, we can check this list over here. And we see there are 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, 12, 13 nodes, unless I forgot to miss any. So 13 nodes expanded, including our start and our goal in total.